Section 9.3, Logarithmic Functions. Now that we know a little bit about exponential functions, we like to learn about type of functions which they undo exponential functions, just like radicals undid what? Exponents. Logarithmic functions undo exponential functions. In other words, they are inverse of one another. Okay, so here's the definition. Y equals log with a letter x next to the g and a subscript b. And the way we read this, we go y equals log of x base b, which means x is equal to b to the y. So that's how we read this. The logarithm of x to the base b, or just simply log base b of x. So let's see if we can read these guys. Log of 49 base 7, log of 1 over 81 base 1/3, log of 25 base 5, log of 10 base 10, log of 64 base 4 equals y, or y is equal to log of x base 3. That's how you read these guys. So back to the definition. When we say y is equal to log of x base b, remember sometimes you can write y as f of x. So this is called a logarithmic function. However, x here next to the letter g is called the logorand, and it must be positive. So what does that mean? That means it cannot be 0, nor it could be a negative number. Whereas b is called base, and some books they use what? Letter a sometimes. So instead of b, you might see the letter a for the base, but I use b, stands for base. Has to be positive number, and it cannot be equal to 1. And y is the value of the log. It can be any real number. So what I'm saying here, logorand cannot be negative or 0 because log of negative 2 base 5 is not defined. Log of 0 base 10 is not defined. And log of 5 base 1, remember base cannot be equal to 1, is also not defined. So basically the bottom line is what? Logs undo exponential functions and vice versa. So there must be a relationship between exponential function and logarithmic function. So here's the conversion formula. So when we say y is equal to log of x base b, that's exactly the same as x equals b to the power of y, meaning logorand, remember this is called logorand, is equal to base to the power of the what? Value of the log. So these are identical. So you can go back and forth between these two forms. So this guy is called log form or logarithmic form. This is called exponential form, and they are equal. So with that said, why don't we just try to convert these exponents into logarithmic form? So in other words, we're going from right to left. So 5 squared is equal to 25. And that makes sense. 5 squared is 25. Let's see if we can rewrite this in logarithmic form. So b is 5, y is 2, what? X is 25. So this should read 2 is equal to log of what? 25 base 5. In other words, this is exactly the same as saying what? 5 squared equals 25. These are identical statements. Here, what do we have? X is 1 over 8, b is, the base is 2, y is negative 3. So this should be negative 3 equals, I'm just following this guy, log of x, which is 1/8 base what? 2. So this guy is equivalent to 1 over 8 equals 2 to the power of negative 3. These are identical statements. What about this guy? This would be like negative 1/2 equals log of 1/4 base 16. In other words, this is exactly the same as 1 over 4 equals 16 to the power of negative 1/2. This guy is equal to what? 4 is equal to log of what? 1 over 81 base 1/3. In other words, 1 over 81 is 1/3 to the power of what? 4. Finally, this guy is the same as 0.8451 equals log of 7 base 10. In other words, this is identical to saying what? Saying, let's see now, x, which is what? 7 is equal to 10 to the power of what? 0.8 what? 4 and 5, 1. So that's how you go from exponent form back to logarithmic form. We can also go the other way around, going from logarithmic form back to exponential form. So in other words, we're going from this form to that form. So first we have to identify what's x, what's y, what's b, so we can follow this formula. Remember, x is the logorand, the number attached to the log sign, and the subscript for the letter g is b, and the number on the other side is y, the value of the logarithmic function. So this guy is equivalent to what? 64 is equal to what now? 4 to the power of 3. And that makes sense. 4 to the power of 3 is 64. This guy is equivalent to 1 over 625 equals 5 to the power of negative 4. This guy is equivalent to what? 4 is equal to 64 to the power of 1/3. This guy is equivalent to 100 is equal to 10 to the power of 2. And that makes sense. 10 squared is 100. This guy is equivalent to 0.62 is equal to what? 10 to the power of what? Negative 0.2076. Question is, now that we know a little bit about logarithmic functions, which is inverse of what? Exponential functions, how would you graph a log? The way I graph it, I immediately change the logarithmic form to its equivalent exponential form. Instead of graphing this, I graph this guy. Remember, these are equivalent statements. To say y equals log of x base 3, that's just like to say x is equal to 3 to the power of y. Because the y is sitting on top of the what? 3 as a power, so I choose values of y. So choose these guys, but find these off of this equation. So I chose negative 2, negative 1, 0, 2, 3 for y. Then what? I substitute these values which I selected, and I found the corresponding values of x. For instance, if y is negative 2, x is 3 to the power of negative 2. 3 to the power of negative 2, you and I, we both know that's equal to 1 over 3 squared, which is 1/9. Remember, exponential functions never are negative. So if y is equal to negative 1, 3 to the power of negative 1 is 1 over 3. And this is basically how am I getting those numbers. So if you kind of plot these points, so the first order pair is 1/9, comma, negative 2. So I would say somewhere out here, 1/3, negative 1, just a notch over, then 1, 0, then what? Oh, 9, 2, way up here, 2, and it goes. Is that right? Suppose this is like 9, and imagine, let's say, I erase all this and go, you know what? Let's say that's kind of like 9, that's kind of like 2. So if you graph this, notice the graph is not gonna what? Touch the y-axis, and this is how it's gonna look like. So this is the picture of y is equal to log of x base 3. So do you see how I got this? By changing this guy to what? Exponential form, and instead of choosing values for x, I chose values for y, but I found these up of the equation, you know, the x values. So I plotted the points, lo and behold, this is how the graph of log looks like. Okay, so now The question is, how would you find the unknowns here, either x or y? To solve the equation with logarithmic function, the best way to do this is immediately change this to what? To exponential form. So this is 25 equals 5 to the power of y. Okay, 5 to what power gives you 25? So y has to be equal to 2 because 5 squared is equal to 2. Okay, log of 1 over 16 base 2 equals y. What is y? Well, that will be 1 over 16 equals 2 to the power of y, correct? So 2 to what power gives you 1 over 16? Well, it turns out that would be y is equal to negative 4. How did you figure that out? Well, 1 over 16 is 1 over 2 to the 4, and this is 2 to the y. But if I place this on top, I have to change its sign. So check this out. I have two exponents, the one on the left, one on the right. They have the same basis. So the only thing is left is what? For two exponents to be the same, they got to have same basis, same powers. So all I do, set the powers equal, and lo and behold, I get the same answer, which is what? Negative 4. What about this guy? What's x equal to? Well, if I change this to exponential form, x is equal to 1/3 to the power of 4, which is 1 over 81. Do you see it? I don't even use calculators, right? What about log of 100 base 10? Well, this would be the same as what? If I let this guy be equal to y, this would be the same as 100 equals 10 to the power of y. But 100 is what? 10 squared, so 10 to the power of y. Two exponents are said to be equal if they have same basis, same powers. So I'm going to set the powers equal, and lo and behold, y has to be equal to 2. And that makes sense. 10 to the power of 2 is 100. What about this guy? Well, that would be like 1 over 125. Is that right? 1 over 125 equals 5 to what power? Well, that would be the same as 1 over 5 cubed equals what? 5 to the y. But I can write this, put that on top of the fraction and write it as what? 5 to the negative 3. Just change the sign of the power. And lo and behold, two exponents, same basis. The powers got to match. So y has to be equal to what? Negative 3. What about this guy? Well, that would be the same as 1 over 14 equals what? 14 to the power of y. Is that right? But remember, 1 over 14 is the same as 14 to the power of negative 1. Then again, I got two exponents, same basis, got to set the powers equal. Y has to be equal to negative 1. Finally, we got log of 10 base 1000, set this equal to y, and say, aha, 10 is equal to 1000 to what power? Well, that would be the same as 10. 1000 is what? 10 cubed. Okay. But the 3 multiplies the what? Y. So you get 10 is equal to 10 to the power of 3y. Okay. Then again, two exponents, same basis, set the powers equal. So then that's like 1 is equal to 3y. So y is equal to what? 1/3. So that would be the value of log of 10 base 1000 is equal to 1/3. All right. Thank you.